Hello guys, and welcome back to Room Spaghetti. Our next speaker is going to be Steven CP. It's a very simple way to say your name. And he's going to speak about how to integrate geospatial data with MongoDB in Python. Other than this, I would like to also recommend have a look at PyBarbecue for tonight, for who doesn't know about it. Who does, perfect. Who doesn't, get a ticket, because it's going to be amazing. And enjoy.
Thank you. Thanks. So, you're right. I'll take it now, because you never know if it's going to come at the end, right? Is PyBarbecue, is there stuff for vegetariano at the PyBarbecue?
Sorry?
Yes, what's the food for vegetarianos at PyBarbecue?
Everything, vegetariano, non-vegetariano, you're going to just enjoy it. Just come.
All right. That was a little diversion. Okay, so this is me, Steve, Citron-Pousty, but I didn't want to make him say that because it's a hard one. That's the sign-up code if you want to sign up. This is the talk is live up on the web right now, talks.thesteve0. That's a 0, not a O, because I'm leet like that. And there's me on Twitter, IRC, and GitHub if you ever need to find me after the talk. All right, the agenda. Learn a little bit about platform as a service. How many of you used a platform as a service? Okay, so well, you used it in the workshop. Like I said in my workshop, you're the only one from the workshop still here, so I'm not going to say it again. A little bit about MongoDB Spatial. How many of you have used Mongo? Okay, so most have used Mongo. How many of you used MongoDB Spatial? Good. Then why are you here? Just kidding. And then I'm going to show some demos. Okay? So to start with, the assumptions are you like writing code rather than managing servers. Is that true? Yeah, for everybody. Who's a sysadmin that's here? Two? Are you a sysadmin and a developer? Just a sysadmin? Both? Okay. So this way you can stop doing the sysadmin stuff. And then you can understand command line, git, and SSH. I feel like that's pretty, everybody should basically understand that by now, yeah? Okay, that's it for the assumptions. Okay, so public service message. This one's just information. Someone comes up to you and you say, oh, have you used platform as a service? And you say, yeah, I've done EC2. No. Not platform as a service. Okay, platform as a service is in the middle. EC2 is what's called infrastructure as a service. So for all those people who didn't attend this talk, at PyBarbecue you go up and you go, hey, do you know what infrastructure as a service stands for? And so what infrastructure as a service stands for is infrastructure in the cloud on demand, right? You say, I want this much machine with this much memory, this much CPU, but then you pick the AMI or you pick the operating system, you configure it, you keep it up to date, you have to configure all the app servers, you do all the DNS stuff, right? And so that's great that we've gotten servers on demand, no fixed cost, no racking and stacking, awesome. But that's not what most developers like doing. The next part is software as a service, right? What's the biggest software as a service out there? Gmail. Thank you very much. Everybody has like 7 Gmail accounts, and then there's like 6 billion people in the world, so there's 32 billion Gmail accounts out there, or users, right? How exciting is software as a service to developers, though? Not very. It's nice that I don't have to run my own mail server, but I can't really do anything programmatically with Gmail, right? It's not an exciting platform. Software as a service handles the application. Most developers want to write the application. So platform as a service is in the middle. Right? And with platform as a service is, developers do one command and they get all their infrastructure spun up for them. And I'll show you a demo of that later. But since I said this was a public service announcement, not just propaganda for this part, I want to name some other platform as a service providers. Who are some other platform as a service providers? Who's the largest online one? Well, sorry, you raised your hand beforehand. You don't have to have the answer. Go ahead and tell me. Roku. That is actually probably the largest public platform as a service provider. Right? What's another one? Google App Engine's another one. Not Google Compute Engine. Google Compute Engine is here. Right? Who else is here? Besides EC2, which I gave you. Who else? Rackspace. Who else? What?
DigitalOcean.
DigitalOcean, maybe? DigitalOcean's more of like a hosting provider. There's a whole bunch of talks about it here. All of the stuff is written in Python. Who else is here? We're just going to sit here and wait until someone says it.
OpenStack.
Thank you very much. OpenStack. This is OpenStack. Now we get to go outside for recess. Okay. So does everybody get the differences between the different levels? So here is Heroku, Google Compute, Google App Engine. What's another one? Staccato from Active State. The reason I want everyone to know about Platform as a Service is I think almost all developers will be using Platform as a Service in 2 to 3 years. You may not be using it now, but given the people I talk to at shows and the enterprise customers that Red Hat has, everybody from startups to large enterprises like PayPal and Accenture have both bought OpenShift to install on their enterprises. And all developers will be using that for all of their projects from now on within PayPal and Accenture. Right, so it's coming for everyone. And the reason I tell you other ones is I want you to try out other ones. I think ours is the best, so I'm comfortable telling you to try out other ones, but you should try several of them. Any other questions about this cloud stuff? No? We're good? Okay, so now I'm going to go into a bit more I'm starting to put more of my propaganda hat on. So you can either start checking your email, or you can pay attention if you want to hear the propaganda. So the OpenShift origin, we're Red Hat, so of course we have an open source project. Right? OpenShift origin is the open source upstream repo for both of our commercial products. OpenShift origin is on GitHub, openshift.github.io. It's all there. You can get a Vagrant and a Puppet script to install it all on your laptop if you want to. It's all written in Ruby. I'm sad about that part. But we love pull requests, so if you want to add anything to it. Online is what I'm going to show you today. This is where we host it in Amazon. And Enterprise is like Red Hat Enterprise Linux, right? You buy the platform as a service. We give you all the bits. We keep it up to date. We keep it supported for years to come. And that's the differences between the products. Any questions? I'm going to try to go through the propaganda kind of fast, because most people don't like propaganda. Okay, so this is what you get out of the box. This is kind of necessary propaganda. For online, we host in Amazon, so this applies only to online. Rel 6, this applies to online and enterprise. With Origin, you can run it on Fedora as well. What's the usual question I get at this point? Okay, we're all going to sit here until someone else asks the question. You know you're thinking it. I just told you we only run on Fedora and Rel.
What's wrong with that?
No, there's nothing wrong with that. That's good. That's great. It's awesome. The next question is people are going to say,
Can I have Ubuntu?
Can I have Ubuntu, right? All the hipsters who need to have Ubuntu. Good thing you came to the first session, otherwise we would be stuck on that first slide. The reason we can't do Ubuntu or Debian right now is that, well, specifically Ubuntu, is they backed a lot of the SC Linux out of the kernel, and we do basically all of our provisioning using SC Linux and C groups. We don't do virtual machines. We do a whole bunch, and I don't know if I'll have time to talk about it, but basically when you create an app, we create a user and then we lock them down with SC Linux and C groups. So there's no VMs, it's all happening through stuff in the kernel. Okay, so that's why you can't have Ubuntu here for now. Out of the box you get Tomcat, Apache, and for Python by default we use mod WSGI, JBoss, and are any of you PHP developers on the side or have a shop with PHP? Then no one cares about Zen Server. You also have Zen Server. Data stores we give you out of the box are PostgreSQL, that's an elephant right there, MySQL, and MongoDB. So all of these things come right out of the box without you having to configure anything. We can also run any binary you want to run. So I have a blog post that talks about running Minecraft servers on OpenShift because it's just a jar file and you can fire it up. But you can also run Play or Couchbase. We have one that runs Tornado, right? Tornado is its own binary. And so you can run Tornado in there if you want to as a web server. The language is out of the box. I'm assuming everyone here is a Python developer for sure. Do you guys, anybody use Java at all in their shops? No? Okay. PHP, we already said no. Node? One Node developer, two Node developer. How many of you haven't played with Node yet but are interested in learning about Node? Right. So that's the great part about Platform as a Service is you spin up a Node app, you try it out, you play with it a little bit, and then you say, this is just for hipsters, and then you delete the whole app and then you don't have to use it anymore. And then you can say, yeah, I've used Node when some presenter asks the question. I have to stay in the middle.
Unfortunately, yeah.
It's the video?
Because of the video.
Okay.
People are watching you, man, because you're famous.
Yeah. So that's the great part, right? You can just use Node right there on the, you can play with it and then delete it. And then Ruby and Perl, right? And so then also because we use standard open source stuff, any of the normal frameworks work. Django, Flask, Bottle, Pyramids. I've done some work on pyramids as well. It all just works. Developer tools, how many of you use Eclipse? Do any of you use Eclipse? PyClipse? We have really great Eclipse tooling, but if you don't, I recommend using the command line. Jenkins, how many of you do test-driven development or continuous integration? So Jenkins is right out of the box. You can just spin that up. And then there's packaged apps if you want them. All right. So I think this is awesome sauce, because as a developer, how many of you have heard of Yak Shaving? You've heard of it because you were in the session, but you've heard of Yak Shaving too? Good. So you two, be quiet for a minute. Yak Shaving, how many want to learn about Yak Shaving? At least one. Okay, so everybody suffers now. The idea with Yak Shaving is pretend you live in like the Czech Republic or Russia or Canada or Norway or Sweden, some cold place, not in Italy. And you have to go get your mail and it's the middle of winter. And you're like, okay, I'm going to then, mail the paper stuff that comes in the box outside. And so you have to go get your mail. It's freezing outside and you're like, oh, I better put a sweater on before I go outside. You realize you don't have a sweater. So you're like, okay, I got to get some yarn. Okay, I don't have any yarn. Okay, I'm going to have to get some wool to spin into yarn. Oh, I don't have any wool. So you go outside and you start shaving your yak. You know, one of those big, what?
Just drink some beer.
But then you don't get your mail. So then you sit there and you shave your yak for a whole day and you have a pile of wool and you still haven't gotten your mail. Right? And that's what happens with me when I try to set up app servers. Right? I have a great programming idea. I really want to get started right away, but then I spend the next 3 days setting up my servers. And then I get them wrong. Like, what was that Python, what was that Apache configuration? What did that line okay, let me go to Google again. Oh, wait, I clicked on the wrong answer and I pasted the wrong thing and now I've messed up the whole file. I got to start again. With Platform as a Service, I don't deal with that anymore. And that's not just for us, that's for any Platform as a Service. Right? So that's why I think it's awesome sauce, because I can just program. Okay, last propaganda slide. There's more. OpenShift has a free tier, and that's free with no time limit. Right? That's not free for 1 year. That's not free for a certain number of transactions. It's free as long as you can stay within our resource constraints. And the resource constraints are, there's 3 gears in the free tier. Each of those you can think of like a server. Each is 512 megs of RAM and 1 gigabyte of disk space. That 512 megs of RAM applies only to the things you are running. So that RAM doesn't count against the OS. Right? Usually there's a bunch of RAM that you use for the OS, and then you have the app servers. This is just for your app server or your database servers or any applications you run. And the 1 gigabyte of disk, still the same thing. It's only for stuff you store. And that's free forever. No metering on bandwidth or anything like that. We auto-scale, and so what that means is as more connections come in, we'll spin up another gear or another server for you, sync your code over, plug it into the load balancer, and automatically start putting connections over, and then we'll spin it back down again when there's no more connections. No beeper calls, no nothing like that. Finally, it's simple pricing. It's only based off of RAM and disk. Right? There is no pricing based on how many transactions you do or how much bandwidth you use. It's just straight up RAM and disk. So you don't have to sit there and try to estimate, like on Amazon, like how many transactions am I going to do and how much bandwidth I'm going to use. All right. Propaganda's done. All right? 30 minutes. We're halfway there. Any other questions? No? We're good? Okay. You want to see a demo, or should I go on to NoSQL and Mongo? All those who want to see code now because they're starting to fall asleep, raise your hand. Okay, and so everybody else, I'm assuming, wants to see more slides. I really find that hard to believe. If you're comatose, raise your hand now. All right. I find that hard to believe. I'm going to do this. I'm going to show you what Platform as a Service looks like. Ready? I'm going to cd to a directory where I want to make an application, and this is how hard it is to spin up a Python app. Comatose. That's it. Right? That one command will now spin up Apache with mod WSGI and configure everything, plug it into the DNS, and then actually make a Git repo on that server, and then clone it locally at the end. Right? So I would argue that if you work in an enterprise, that's way faster than it would take for you the time to even find the phone number for your sysadmin person. And then if you work in a startup, you don't have to spend any time with your AMI. It's going to spin up faster than an AMI would. Okay? We'll come back to it though, because I'm going to start the slides, because watching this provision, do you want to wait to check my claim that it's fast? You don't want to wait, you believe me? It's too late, it already finished. It's done. So now what it's doing is we actually made a real DNS entry. not just some fake one. So there's a real DNS entry, and we're waiting for this so that we can do the git clone. I say yes. Now it's doing the git clone, and done. And there's my app. It's up and running. Right, so in that time, I've spun up a Python app. And it's running. You want to see a code change? Now that I've got it running, who wants to see a code change? Thank you. Right? So I go into my Git repository, which I called Comatose. Right? You can see this is a Git repository. There's the .git. Right? I cd to WSGI. That file that we were just looking at is this application file. Avoiding religious wars, I will use nano. Right? You can see there's all our Python. It's really complicated Python. At the beginning, it's basically just telling it to load this HTML page and serve it. So now I'm going to impress you. Actually, the only reason I use nano is because I'm so agile and lightweight. VI and Emacs are too heavyweight for me. It's not included in the platform. Nano isn't? Yeah, I know. It's not that hard to have it included, though. We have it on OpenShift, though. It's there on OpenShift. Welcome to my favorite app after lunch. There's my awesome code change. I make my change. I do a git commit. So I've committed it to my local repository, and then I do a git push. Right, and that's it. So now we're pushing back up to the server, the gear that we've provisioned. The git push out there. The git push has happened. Now we wait a few seconds, and then you'll see that we've written a hook for the git push. There. Since this is the first time I'm pushing it, it's doing a stop of the server and a restart of the server. I can actually put a marker in to stop it from doing that. You can see we would have pulled in dependencies there. And we're done. Starting done. And there's my change. Right? So that's what it... So the point is, only time I use RHC tools, like our tooling, is to provision infrastructure. From then on, it's just Git and SSH. Right? So as long as any tooling you use uses Git and SSH, you can basically do all your development work. Right? And I'm not SSHing in now, but I will in a minute. All right, so now we'll go back to the slides. So now you can all say you've seen Platform as a Service and you know what it is. So a bit about MongoDB. In the NoSQL world, MongoDB is what's called a document store database. So that means we're actually storing documents. In this case, you can think of them as JSON documents. Not Word documents, but JSON documents. And in terms of Python, you can think of them as a dictionary. Right? There's a key and then there's a value, and that value can either be more keys and values, it can be more arrays, it can be simple objects. That's a document in MongoDB speak. Okay? They can be nested. So documents can be nested, and this is one of the places where people first started using Mongo. So how many of you have used Foursquare? The check-in service? All right, so Foursquare is a social check-in service. You say, here's where I am, I'm checking in. What you can do here is you can have the location and all the check-ins in one document. Right? So if you wanted to pull that back to the browser or to the phone, you just do one request and there's no joins. You just pull back the entire document, serve it up to the user, and you're done. So it gives you great speed advantages. The problem is each of these comes with a cost, right? The cost is maintenance is harder. Because if you change a value somewhere, you haven't actually changed it everywhere it could be. It's schemaless. So what this means is it doesn't enforce, and like in a relational database, you have a schema, and this column holds ints, and there's only these 5 columns, and if you try to insert a 6th different column, the database will say what? No way, you're trying to insert something, I don't know where to put it. Mongo doesn't care. You can add a new attribute on the fly, and it'll just accept it. You can add a new table, which they call a collection, on the fly, and it won't care. You can just add whatever you want on the fly, and it'll just start accepting it. Great for rapid iteration, because you don't have to call your DBA to add a new column. It doesn't update the indexes for all the new columns, and the tables don't take a long time. Bad because if you put a typo in your code, so if you put people versus you put a P-E-O-P-L-E or P-E-E-P-L-E, those are two totally different attributes according to Mongo, and won't complain because it's just a new attribute, and you'll have data going into two totally different attributes. So cost benefit again, right? It's nice for fast and rapid, not so safe. Basically what you're doing is you're moving the schema into the application code. It's really good at fast writes, right? It has the ability to basically return back to the connection and say I've written, even after it's only either written to disk in one place or even after it's written to the network stack, right? So you could say, oh yeah, I got the connection, I got your network, I've got your transaction, I'm done, but it hasn't even written it to disk yet, right? So it can do that if you want it to. And it's also easy to horizontally scale. So horizontally scale is you add more of the same type of, lots of small more servers rather than making your one server bigger. And it's very simple to automatically set that up with Mongo. So that's why some people use it as well. Any questions about Mongo? We're good? Okay. Now on to some spatial. Does everybody know what I mean by spatial? Like mapping? Right? Good? Good. Mongo is very limited in terms of what it can do in spatial. It can only do near, so things that are near where you are. Containment, things which are within another shape. And intersection. So do these two things cross? Those are the only three functions it runs, right? Which doesn't seem like a lot, but actually for most use cases, this is enough. I would say probably 80% of applications will never use more than that kind of spatial functionality. Any application that's like pins on a map, you don't need anything more than this. It's all laid out here on these two pages, right? So remember this talk is up on the web. You can bookmark it and go to the links for those two pages. I don't want to go too in-depth onto the indexes, given the time. Okay, and there's two types of indices. This is actually stuff I didn't cover in the workshop. There's 2D for flat surfaces, and 2D sphere for when you're dealing with coordinates on an Earth-like sphere. Okay? So if you're getting GPS units from a phone, which one do you think you should use? 2D sphere, right? Because that's actually coming, I think it's on the Earth. 2D you would use for something like if we wanted to map this room, right? You could say that corner was 0, 0, and then we could map everybody's coordinates relative to that corner. And then we could put that into the database, and we could say, what's the closest people sitting next to me? Which people are sitting within this box in the room? You could do any of those. You could do it in your backyard. Any of those things. Good to know. They all assume that the coordinates are between minus 180 and 180. Why? Exactly. That's how we map the globe. That was not a trick question. The globe, it never gets bigger than minus 180 or 180, right? That's as high as it ever gets. But it can handle any 2D coordinates, so if you make an index that's bigger than that, like if we did this room in centimeters, you'd have to tell the index, I want it to be these ranges now. The other thing is, because it is agnostic about units, whatever you put in is whatever you get out. So if you're putting degrees in, you're going to get degrees out. So it has formulas to help you handle curvatures of the Earth, right? Because on a globe, what happens to lines of longitude? They come together, right? Don't you remember, like looking, they all come together at the top? So 1 degree at the pole is not the same as in distance as 1 degree at the equator. So it has methods to handle that. It has also formulas to convert to human readable units. Most people think in kilometers, not in degrees. So you can actually go back and forth between kilometers or miles. If you're American, you think in miles. Everybody else thinks in kilometers. Okay, we're almost done with this part too. How to make it work? You put your coordinates into an array. So you define an attribute, then you put an array on it that has your coordinates. If you're doing spherical, make sure to put them in as longitude and latitude. Does everybody see how that works? The first one is the best example. There's location, a field, or an attribute called location. Its value is an array with 2 floats in it. And then you just make an index on it. So DB places, this is the collection, or like the table. Ensure an index, so this is the Mongo speak for making an index. Location, oh I'm supposed to stand there, but location matches that name up there, and the type of index I want to do is a 2D, or it could be 2D sphere. And that's it, you're done. That's all you need to do to make your database spatial. Okay, so the example is I downloaded all the data for the national parks from the United States and Canada. and it looks like this. Or I converted it to make it look like this. There it is. It's very exciting. Each of these is what's considered a document, a JSON document. There's a name, that's the name of the park. There's a field, another attribute called pos. That pos is the position of the park, and there's longitude, latitude. 547 of them. Okay? So what I did in my code, in my application, I've already done this. All right, I took this Git repo and moved it up there. And then I ran this command, Mongo import. Mongo import is the bulk loader for Mongo. And what I'm doing with this is I'm saying import into the database called Python WS into a collection called park points. The input's going to be a JSON file. The location is in my repo directory. And it just sucks it all in and puts it in. And so now I've got 547 documents in there. And then I go into Mongo and I say, that makes it really hard to look at if I do that, doesn't it? I say db park points. So that was the name, remember that's the name of the collection. I say ensure index and of type 2D. And now it's spatial. Right? So I will show you that data set now. So I'm SSHing in to my gear. This is the gear I created before. We could have done the same thing with the one I created for here. We're in, and now I say Mongo, and now I'm playing with MongoDB. Right? So for those of you who haven't tried Mongo so far, this is also another easy way to start playing with Mongo. Create an OpenShift account, make a Python app, add Mongo to it, and you've got Mongo to play with. All right? Now I'm going to use Python WS, db park points, find. This is in SQL speak. This is like select star from table. And there's all our records. Right? And what you'll see has been added is this ID field. This is the auto-generated ID from Mongo. It's a hash of like the date, the time, and the machine, and they're guaranteed to be in timestamp order. So you can actually sort on that field and they'll be in timestamp order. All right. So then, how many of you have used Flask? Most, but not all. Okay, the part that I used of Flask, Flask actually provides templating. The only part I used of Flask is the URL mappings. Right, so the nice part that I like about Flask, I'm a strong believer, I'll give you the background on why I do this. I'm a strong believer that server-side developers should not write HTML. I hate templating, because server-side developers are usually terrible UI, UX people. They're great at accessing databases and putting data together and doing all sorts of complicated business rules, and then they're miserable at putting UI together. And then UI and UX people hate using templating languages because it doesn't match their tools. So what I really like is REST services on the back end, and then the client consumes them however they want to consume them. Right? No templating needed for that. Or maybe the templating is providing your JSON stream, but nothing more than that. So I have a strong bias, and I'm revealing it now. So what I love Flask for is it's lightweight. It doesn't have it's not highly opinionated, right? So Django I consider to be highly opinionated. It has a very certain way it wants you to do things. Same way like Rails. I consider Rails highly opinionated as well. So I'm using Flask for just some great URL remapping. If you use Flask, make sure to put in the propagate exceptions field to true. Otherwise Flask swallows the exceptions, and you'll never know what's going wrong with your code. Okay, so the first one is app route. So I'm saying anything that comes into this application to /ws/parks, we're going to set up the Mongo connection. So in the cloud environment, you always use environment variables. Never use hard-coded IPs or usernames or any of that. So you can see I'm grabbing from the environment the OpenShift. Is that seconds left or minutes? How much is?
It's minutes, but if you want to do QA, if you want to do QA.
No, they're getting chance to QA all along. They can. You guys know I'm informal, and if you have a question, you raise your hand, right? Everybody's feeling that?
Okay.
Yeah.
I didn't know.
But now you do, right? Because I've been very formal and stiff up until this point. Yeah. Okay. But now I'll loosen up a bit. Notice that I'm grabbing from the environment the URL for the database. OpenShift puts that in there for you, right? So that this code will work with anybody's app. And then I'm taking the app name to make the connection to the database. I get a connection to the database, then I ask the connection for a handle to the database. That's line 18 and line 19. Okay, that's PyMongo. So that seems pretty easy to me. Does that seem pretty easy to everybody else to make a connection to a database? Pretty much, yeah? I think so. Coming from the Java world, it's awesome. I love it. Okay, and then this is it. db.parkpoints.find. That's my query. What does that look like? Okay, was everybody sleeping during the part where I used the console? I saw eyes open. Yeah, it's the same. Thank you. It's exactly the same. Look, ready? I'll do it again. db park points find. See that? Look at that. Exactly. And it's the same. So this is what I really love about Mongo. One of the things I think I highly, highly respect them for is their driver writers. The people who have written the drivers for Mongo have done a great job of making it feel like your language, but also making it pretty close to the console, so it's very easy to go back and forth and debug and to figure out what you actually need to do. It's not some like impediment mismatch where you're using some special language, getting back this special like result set thing or something. It's basically comes back as a type of object. So I do that same query. I know I'm supposed to stay in front of the camera, but I'm moving over here because I'm going to point to lines. So for those on the camera, I'm pointing to line 25. I'm just trying to help him out. You can see here's the result, right? I said here's result that I get back from that find. I'm casting it to a list. I'm adding it to a dictionary. And then I'm calling dumps and I'm telling it to use JSON util default. Right, so that's JSON dumps, then I'm casting that to a string and I'm done. And what it gives back, so if we remember I said I mapped that to /ws/parks. There's the JSON. And I don't know why it does this. For some reason you know what it's probably not doing it. I know why it's not doing it. So watch, I'll show you. What I was complaining about is if I do this, here's another web service I wrote in Java that it's the exact same thing. I ported that same sample to Java and Node. See how that's nicely formatted? That's exactly what the other one looks like. It's because I'm not setting the MIME type. I didn't set the MIME type in Flask. I should update my example so that my browser doesn't know that this is JSON. I should set the return type to application/JSON. But anyway, trust me, it's the same data. Right? It's 547 JSON objects, each of which has the ID, the name, and the position. Okay? So that's kind of an interesting query. I'm going to show you the next query though now. So here I'm going to show you how Flask grabs something out of the URL. So you see how the URL is in angly brackets? That angly bracket at the end, it's saying anything now that comes into WS park, whatever comes after that last slash, grab it and use it. And actually, we're going to pass it into the function that this is going to call. So you see how there's def one park, and then it's got park ID in there. That means that what was ever in the angly brackets in the URL gets passed into the function. All right. So what do you notice right away about my code? This is not production ready at all, right? Did I check what park ID contains at all? No. So if you ever use this code and I catch you using it straight as is in production, I will hunt you down because this is bad code for production, all right? But it gives you an idea. You'll notice the first two lines, the connection and the database are the same. What's different is in the result, I do db park points find, and then I have to cast that string that's coming in from the URL to an object ID, which is a Mongo type, because the object ID is actually an object. But then this line is the same, right? So the only thing that's going to change from now on is stuff that happens in here. So here we can do this one, right? Let's say I like this African American Civil War memorial, and I think this is its object ID. So he said WS park/park, and there's the one park back, right? So now, so you see how that worked? Very nice. And I could actually go back into Mongo if you wanted to see it, but I'm not going to do it, and do this db park point find and pass in that object ID right there as well. Right, that's the exact same syntax in the console. This part right here, line 36. Okay, next type of query. This is the one we've all been waiting for. Near. Right, so here I'm actually going to query against the latitude and the longitude. And so what happens is there's nothing coming in through the URL, it's coming as query parameters. Right, and so what I'm doing with the query parameters is see the request.lines 50 and 51, right? Request.args.get. So that's how Flask gets the request arguments. So I'm getting Latin long, casting them to floats to Latin long. See why this is not production code? Right? That is not, there's no error checking on that at all, or even if they exist. I'm assuming they're there, and then what I'm going to do is do a park points find against the pos field, show me things near, and then I make an array again of the latitude and longitude, and I find them. Where are these coordinates going to probably come from in your application? The phone, right? Yeah, I open up my phone, the phone says, oh, I'm going to grab your GPS coordinates, and then you're going to pass it into this function and find out things near you. In Foursquare, this is the opening screen to Foursquare, for those of you who've used Foursquare, right? So we can go back here, right? And so it's WS parks near. So I go to the URL, I paste this in, so WS parks near. And there's all the parks that are near that coordinate, right? And they're always going to come back in distance sorted order, right? Once you've used a distance query, you cannot change the sort. The sort will always be distance from the original point that you passed in, okay? And for those of you who are wondering, this is somewhere up in Michigan, Michigan, United States. Okay? Yeah? No, this one has a cat, because I didn't do find, there's like some query, the cursor size or something for the query, I think it's 30 or something like that. I think it's 30, but I'm not exactly sure. Okay? I mean, if I had the nice layout, we could probably count how many, but I don't. The other thing that you should know about this, you just made me think, no limit. Good question. The other thing I could have done in this code, suppose you know, in here on line 54, you can do a less than for the near, right, or a greater than. So you can say, you know, it's not going to be more than 5 kilometers away. You don't care anything past 5 kilometers. You can do a less than 5, whatever the conversion is to 5 kilometers in degrees. You can pass that in there, and it'll only get things within 5 kilometers. Right? Because a lot of times, especially for a check-in app, if it's more than 5 kilometers away, you're like, it's not a real place that they're at. Any other questions on that? So that's it for, you've just seen all there is to do. If I go through it again, you can have a spatial application up by spinning up OpenShift, importing some data, writing a little bit of Flask. I mean, this is the only query that you need to really do to do a mapping service. Using that service, wait one sec, I do this. I can make this. This is hitting against the Java service, but the REST contract stays the same. There's a map, that's the map interface to that same thing. All right, that's the map to the REST service. I'm using OpenStreetMap. How many of you have heard of OpenStreetMap? Yeah, because we're in Europe. If I asked that in the United States, it'd be like one hand in the room. All right, I love OpenStreetMap. So it's using Leaflet, and here I am querying for parks, and you can see how fast it is. Like I'll query all the parks here. 7 minutes. All right. But does that 7 minutes include the 5, or I have 2?
No, you got 12 minutes.
12? Oh. But wait. Really 12?
Yeah, 12. Because it's 7 minutes plus 5 minutes.
Okay. Done. 12. Because there was all these different 5-minute things rules that came up. So that's the service running there. And all that's doing is it's a JavaScript front end calling into a REST service. Okay? All right. So you can also combine spatial queries with names, because usually when you log into, I don't know how many of you use Foursquare, but usually when you log in, it never finds your place in the first list. But you know you're at a gelato place, right? So you always say, okay, well I want a gelato place within nearby. So I change the service. Here's another URL. Oh wait, you had a question. Go ahead, what's your question?
Oh yeah, my question was, did you ever make any performance comparison with, for example, PostGIS, Spatial?
No. So you're asking the question, the videotaper is here. Did everybody else in the room hear it and understand it? So PostGIS has a spatial extension called PostGIS, which is more complicated to set up, but way more powerful. Like if you really need to do a lot of spatial functionality, you should totally use PostGIS. I love PostGIS. I've committed to the docs. I've given tons of talks on PostGIS. I haven't done any performance comparisons. I mean, part of the reason for this is it's simple and easy, and you don't have to change your schema. There's no extra metadata to keep track of. But in terms of performance, I don't know. Okay. I've never done it. It's a job for you. Blog post for you, right there. Okay. And the nice part is using OpenShift, you know the hardware will be the same.
Okay.
That's right. You can spin up we have PostGIS out of the box too, so you can use both. Now there's no excuse for not writing that post. I got rid of all your excuses. All right. So again, here we're going to do WS Parks name near, and then the name you want to search on. Right? If I was to rewrite this REST API, I would get rid of this name part right here. I would just call it WS Parks near, and if there's a name there, then I would do, and then the near query against it. But it is what it is. All right, the connections are the same. The lat long's the same. This is the new part down here, line 72, right? So what do you notice is I'm using a Python regex. Right? I don't have to write some sort of fancy regex that Mongo understands. The driver writers did it so that you pass in a Python regex to execute the regex against Mongo. Right? So I make a Python regex. I say take the name field that's in the URL, you reuse it here. It's case insensitive. And then in the query, I say find name, and I pass in the regex for the name, and I do pause, the same pause query again. So now, in here, it's parks / name / near, and then the name. So I always usually do Lincoln. I'm going to do Washington and see what I get. There. Right? So these are only places that have the name Washington in them, and they're in results are in distance order from the coordinates passed in. So you see if I can change these coordinates quickly. Let's see, if I want to try to if I'm in Michigan and I want to get to Virginia, I'm going to do like 73, and I need to go further south, so that would be like 34, 35? Still, oh no, it's waiting on that. Or did my phone die? I'm tethering to my phone. No, my phone's still alive. It's stuck. Did I do something funky? No. Let's try it again. You just saw how fast it was a second ago. Oh, it's back. It just didn't change anything, did it? Go to there. So now I've flipped south. I'm south of Washington, D.C., and you can see the closest place is Booker T. Washington National Monument, which is probably in the south somewhere. Okay? So it automatically updates it on the fly. All right. So that's basically it for my talk. I think that was my last Flask example. So everybody understand Flask a little bit now, at least for URL rewriting, and see how easy it is? I mean, it's very, very easy to make a JSON REST service. I should expand this in the future to also include, I'll expand this. There's two things I wanted to add. What was the first thing? Oh, the MIME type. And the other thing I should do is show a post. A post is just as simple. All of these are assuming gets. I think it assumes get unless you just say what type it is you want to return. I probably do like an app post rather than a get as another annotation. All right? So last slides. OpenShift makes life great for you. This is the last propaganda. Spatial is easy and fun with MongoDB, and it's free. So you can try all this for free. If you want to hang out with us, we are on OpenShift on Freenode, and if you use IRC. And then if you want to send an email, users@list.openshift.redhat.com. That's it. Thanks, everyone. So if there are any questions, yeah, I got you afterwards.
Hey, do you know any platform as a service for OpenStack? I mean, yeah.
So, actually, to most platforms as a service don't care what's underneath of them, right? So in our example, we don't care if OpenStack is underneath of us. All we want is rel. Red Hat does offer an OpenStack distribution, and you can put OpenShift on top of OpenStack. You could any infrastructure as a service, you can put Red Hat on top, OpenShift on top of that. Because we just need, it could even be, we could be on top of, if there's one public one. I think Rackspace has OpenStack. Is it okay if I hand it back to him?
Yeah.
I don't want to bother you.
No. It's
The multi-purpose man.
Sorry, say that again?
The multi-purpose man, you are able to do everything.
I can do everything.
Jacob of
Yeah.
trades.
Welcome to my party. Have some wine.
So
A little bit of fromage. Go ahead.
The question is, are there plans in the future to enhance the support of MongoDB for spatial activities, let's say? And
More functionality
yes,
in Mongo?
Yes.
So I've talked to the spatial guys at Mongo. Yes, there is. So as of now, with 2.4, they also support GeoJSON. So you can take GeoJSON and put that straight in, and it understands it. As a matter of fact, that's what they're going to want people to do for spatial, is to put GeoJSON in. And then I was talking to them, it's all C, it's all written in C. So I told them you should put Geos with it, and you should put Proj4 with it. And so it's on their long-term roadmap, so that it can do more things like PostGIS, because that's what PostGIS uses under the hoods. But the more people that ask for it, the higher it gets bumped. It's like with any of these software projects. The more people who ask for it, the higher it gets bumped up. Right now, most of the people using Mongo are not really using it for spatial. Some are, but not the big paying customers. And so it's not as high up on the roadmap.
I see.
But they do have plans for it. I just don't know where in the roadmap.
Yeah. Do you know any live?
1 second.
Do you know any live examples of production services which use MongoDB as a special
Foursquare.
database? Okay. Also,
Yeah.
Any other one? Yep.
That Foursquare cannot do with this setup. So you said PostGIS is better. So
Foursquare,
they have any
I think
problems?
Foursquare has got into problems where they're starting to move. The spatial doesn't do all the querying that they want. Is that me? Am I too far forward, or was that you? I thought I heard some feedback. Okay.
I don't know what happened, right?
Okay. They've started to implement their own on top of. They've started to implement their own spatial functions on top of this, doing some stuff with Hadoop and other things. The question, what was? Sorry, I forgot the last part of it though.
if they run into any problems with the setup, so actually you said Postgres is more powerful.
But
so
it's more powerful in terms of the amount of spatial functions it has. It's not necessarily more powerful in terms of like how much data it can index and that kind of stuff. It's just that, like, if you want to do something like a buffer. So a buffer means take this point or this line or this box and go out 5 kilometers from this point and make a new circle based on it, or take 5 meters or 500 meters off a lake and make a new polygon based off, or a new line based on that, and then tell me all the points inside of that new space. PostGIS can do that in one query, right? Or it can make all new features based off of that buffer, or it can do clipping, like only take the lakes, clip them with rainfall catchments or something else, and only give me the polygons left where the two match up together. Like that stuff you can't do in Mongo, but PostGIS does it like right out of the box.
okay, thanks.
So it just depends on what. For me, if I was doing this myself, and I was only doing lat longs out of a GPS, and I wanted to store documents rather than normal tables, I would use, and I was going to just do near, I would use Mongo. But usually, I store more than documents, and I like schemas. Some people don't like schemas. I love schemas because it prevents. I'm error prone. It's the same reason I like IDEs. I do typos all the time. I try to do things which aren't supposed to be done, and I like when my tools stop me from doing stupid things. So, Yeah, in the back.
You say before that there is some code to give conversions of units, but then you say that there is no proj in Mongo.
That's
so
right.
it doesn't have any constants of projections, or
Right, there is.
so it works only in 4326 or in VGS 84, or
It doesn't care.
it doesn't care at all.
It doesn't care. It just says, give me units. Give me an X and give me a Y. And so it's up to you to make sure that either your formula can convert that to real units or project it and store. There's nothing to stop you from putting in projected units into your database as well and indexing on those instead.
One more question about the OpenShift. Is it any customizable? I mean, anyone runs into the problem with customization, maybe add new functions to the, comments to the RHS.
So which part do you want to customize? It depends. So let me try to, so the idea with, and are you talking about online?
Yes.
Okay, so for online, that we host it, right? So what you can do is add your own cartridge. You can make your own cartridges, right? So let's say you want to do, we don't have a Redis cartridge right now, but someone in the community has started to write a Redis cartridge.
Oh yeah, exactly. This is what
That's
I'm
the thing
asking
you're looking for? Yeah.
Yes.
So there's if you go to the Red Hat booth, there's also a guy who's written a DIY, like a quick start for Tornado, but we're trying to get him to convert that into a cartridge now. So if you wanted to run Tornado, where I said this before, where I said this before, now I closed it all. Where I said RHC app create and then Python 2.6, instead you say RHC app create comatose, and then you give the URL, and it downloads the manifest, and then downloads all the pieces, and then runs it.
Okay.
So it's like a build pack, and if you've used Heroku, it's like a build pack in Heroku, right?
Any other questions? All right. Thank you very much.
Thanks, everyone.